Okay, let's unpack this. I want you to picture a specific moment in time. It is Monday, February 16th, 2026.
A date that will live in infamy.
For one developer, absolutely. It's 3 in the morning. Most of the world is asleep, but we are zooming in on a user. We'll call him the architect. He is burning the candle at both ends, trying to get his software platform, Beatite Flow, ready for launch.
Witching hour for engineering. Nothing good ever happens at 3:30 a.m.
He's sitting there staring at his screen, trying to categorize his own transactions. He's basically dog-fooding his own product, using it to run his own books, and he hits a wall.
And we aren't talking about a little glitch or a typo. This is a stop the presses, I cannot trust my own creation kind of wall.
He is stuck on transaction number 2. I mean, literally the second transaction he tries to process. It's a bank deposit from Stripe for exactly $980.06.
Okay.
And he has absolutely no idea what it is.
And that confusion right there, that's the spark for this entire deep dive. Because what we're looking at today isn't just a story about fixing a bug. It is really a masterclass in how a frustrating UI problem evolves into a bulletproof, mathematically deterministic financial control system.
It's the story of how I want it to work like QuickBooks turned into I want this to be audit-proof. So set the scene for the conflict here. We have a deposit, $980.06. Why is this causing a mental breakdown at 3:30 a.m.?
To understand the panic, we have to understand the disconnect between how a human sees money and how a payment processor, like Stripe, moves money around.
Okay, play that out for me. I'm the user. I see money hit my bank account. My first instinct is to click add and call it sales.
Well,
Why is that catastrophic?
because you're thinking like a human, not a ledger. In the software's brain, that money was already counted. It was counted the second the client clicked pay on the invoice, maybe 3 days ago. That was the revenue event.
So the system already knows I made the money.
Correct. It's sitting in a holding account, a virtual bucket,
Yeah.
This new deposit, it's just a transfer. It's moving money from your left pocket, the virtual Stripe bucket, to your right pocket, the real checking account.
But hang on, money did hit the bank account. If I don't call it income, what do I call it? It feels, I don't know, unnatural to ignore cash hitting the balance.
It feels unnatural, but it's accounting 101. That cash isn't new money, it's moved money. If you label that transfer as sales or income again, you are effectively telling the tax man you made that money twice.
You're doubling your revenue.
You are doubling your revenue figures for the year, yes.
Which is a great way to overpay your taxes, but a terrible way to run a business.
Exactly. And this is where the panic set in for our architect. He realized that if he categorized this batch wrong, he'd have to unwind months of bookkeeping later. He realized his system was asking him a question. Who is this money from? And he couldn't answer it.
Because Stripe doesn't tell you, right? They just dump the money.
They dump a batch. That $980.06 isn't from one client. It's actually a bucket containing 7 different client payments minus the processing fees for each of them. It's a black box.
So Byteflow is just seeing money coming in and asking the user, hey, do you want to categorize this as income? And if the user clicked yes.
Disaster. Total data corruption. The user, quite rightly, flipped out. The logs from the session are, they're intense.
Yeah.
He realizes that if he doesn't know what's in that batch, he's just guessing, and he refuses to guess.
I'm looking at the notes here, and he actually says, if a client pays, that client's payment should be paid out alone. Unless that happens, I do not trust this system.
Wow.
He actually threatened to go into the Stripe dashboard and manually trigger payouts one by one just to avoid this whole batching issue.
Which would be an operational nightmare.
Mm-hmm.
Can you imagine manually processing thousands of payouts just to keep your bank feed tidy? But the developers, who are practically co-piloting the session with him, they realize they need an immediate fix.
Right. And this is where we get into the engineering side. Step 1 was just stopping the bleeding.
Right. They had to implement a logic guard at the very deepest level of the system. It wasn't just a UI warning. They hard-coded a constraint into the back-end processing engine, the deterministic. It fundamentally forbids categorizing a Stripe payout as income.
So even if I'm tired and I try to force it, the system just says no.
It blocks you completely. If the transaction description contains Stripe transfer or Stripe payout, the option to select income is physically removed.
Yeah.
Gone. It forces you to use a clearing account, usually called undeposited funds.
Okay, so that stops the double counting. But the architect still has this $980 mystery blob. He still doesn't know which clients are in there. And he keeps saying, make it like QuickBooks.
Which is the gold standard for many small business owners, right?
But if QBO deals with batches too and they hide the complexity, why couldn't Bitflow just do the same thing? Why drag the user into it at all?
Well, that was the debate. But they realized that unlike QBO, they didn't have the historical data to guess effectively yet. QBO has millions of users and, sophisticated machine learning that can look at your history and say, usually $50 comes from Bob.
Ah.
Bitflow was starting from scratch.
So they needed a manual bridge.
Exactly. They realized they needed a dedicated UI. They built a new feature where instead of a generic add transaction button, Stripe Rose got a special match payout button.
And when you click that, what happens?
It opens a modal window, a pop-up. The system looks at all the payments in the database that haven't been deposited yet, all that stuff in undeposited funds, and it tries to find a combination of them that sums up to the deposit amount.
So trying to solve a puzzle. Which of these individual payments minus their fees equals $980.06?
That was the initial approach, yes. Yeah. It was what they call estimated matching. The system would look at the dates and the amounts and say, hey, these 7 payments look like they fit. Is this right?
But the user wasn't having it.
Not at all.
He looked at those checkboxes and said, I am not going to guess. He realized that if he has to manually select checkboxes to make the math work, it's still prone to human error. He wanted certainty.
And this is the pivot point of the entire deep dive, the shift from guesswork to exactitude. The user demanded a system that was mathematically accurate and secure. He didn't want a suggested match. He wanted the actual match.
So how do you get that? If the bank feed just gives you a lump sum and a generic description, where do you get the detail?
You have to go to the source. The developers realized that the bank description for the deposit usually contains a token. It looks like ST followed by, a bunch of random letters and numbers.
The Stripe payout ID.
Or a reference to it, yeah. So they rewrote the backend logic. Instead of just looking at internal database records and trying to do math, the system was updated to take that token, reach out to the Stripe API directly and say, hey, Stripe, tell me exactly what transactions are inside this specific payout.
That sounds much better. It's like asking the bank for the receipt instead of trying to remember what you bought.
In theory, yes. They implemented this exact resolution logic. It queries the balance transaction endpoint at Stripe. It gets the list of fees, refunds, and charges, and then it maps those back to the invoices in Valueflow.
So they have the plan, query the Stripe API, get the data, match it to the invoice. Sounds pretty standard for an integration. Where did it go off the rails?
It started with permissions, and this is a classic developer versus platform struggle. They deployed the code, the user clicked the new match button, and nothing. Silence. The logs just spat out a permission error.
Was the API key wrong?
The key was valid, but it was essentially blind to the specific data they needed. Stripe uses scopes, these granular permissions. Their key could see charges, but it couldn't see balance history.
It's like having a key to the building, but not the file room.
Precisely. They needed a specific scope called rack balance read. It's obscure. It's the permission required to see the nitty-gritty of the balance ledger.
So this isn't something you can fix in code then?
No, and that's the frustration. The user actually had to leave the Bitflow app, log into his Stripe dashboard, navigate through the developer settings to the API keys section, find the connected account settings, and manually flip a switch to grant this specific access.
Okay, annoying, but solvable. He flips the switch, saves it, comes back to Bitflow. Does it work?
You'd think so. But this brings us to the second bug, which is actually much more intriguing from a security perspective. It turned out to be an encryption mismatch.
Wait, how does encryption break a search for a transaction?
Well, Bitflow is paranoid about security, which is good. When it saves a Stripe reference ID in its own database, like the payment intent ID, which starts with pi, it encrypts it, it turns pi123 into a completely scrambled string of nonsense characters.
Smart. So if they get hacked, the data is useless.
Right. But here's the flaw. The new code they wrote was trying to run a SQL query. It took the raw ID it got from Stripe, let's say pi123, and asked the database, hey, show me the row where the reference equals pi123.
But the database doesn't have pi123. It has a scrambled mess. So it's like, okay, imagine looking for a book in a library. You have the title in English, The Great Gatsby. But the library catalog is written in a secret code. You ask the librarian for The Great Gatsby, and she looks at her coded list and says, sorry, I don't see that here.
That is the perfect analogy. The book is right there on the shelf, but the names don't match because of the encryption layer, so the query returns 0 results. The system thinks the payments don't exist, and it falls back to that hated guessing mode.
So how do you fix that without compromising security? You can't just store the data in plain text.
No, you absolutely cannot. You have to change where the matching happens. They had to stop asking the database to find the match via SQL. Instead, they had to pull the encrypted records out of the database and into the application memory.
Into the secure environment.
Right. They decrypted them there, safely behind the firewall, and then ran the comparison against the list they got from Stripe.
That is such a subtle catch. Once they fixed that, decrypted the local data to compare with the API data, what happened?
The aha moment. The system successfully identified exactly 7 payments. The gross amount was $1,011.50. The fees were $31.44, and the net deposit was exactly $980.06.
The math worked.
The math worked perfectly, and not because the system guessed, but because it traced the cryptographic tokens from the bank to Stripe and back to the invoice.
This brings us to the final evolution of this feature. The user wasn't just happy it worked. He wanted to make sure it couldn't fail in the future. He started talking about being audit-proof.
This is where we see a shift in philosophy. We move from just functionality to controls. The user insisted on what we call a fail-closed architecture.
Fail closed. Break that down for us.
Most consumer software is fail-open. If the software isn't sure, it guesses. It says, hey, this looks close enough. Do you want to accept it? It prioritizes convenience over accuracy. It tries to be helpful.
Like the old Microsoft paperclip. It looks like you're trying to reconcile a payment.
Right. But in finance, helpful is dangerous. Fail closed means if I cannot verify this transaction with 100% mathematical certainty using the API, the token, and the math, I will simply lock the door. I will disable the button.
You literally cannot proceed.
You cannot proceed. They updated the system so that if Bitflow cannot get the exact payout composition from Stripe, maybe the API is down, maybe those permissions are wrong again, the confirm button is disabled, it explicitly says exact match unavailable.
So you can't force a bad transaction into the books even if you wanted to.
Exactly. It prevents human error by removing human agency from that specific step. The button even changed its name from match payout to confirm exact match.
And to top it all off, they created documentation artifacts. I mean, if you're going to be audit-proof, you need proof, right?
They generated templates for a payout reconciliation certificate. It's a document that proves the math for every single payout. It lists the bank transaction ID, the Stripe payout ID, every single included payment intent, and the exact fee calculations.
And an audit trail extract I see here.
Which shows who clicked the button and when. And finally, a control statement guaranteeing that no payout affects the books without Stripe verification. This is the difference between a tool that works and a tool you can take to an IRS audit.
It's impressive. We started with the guy screaming at his computer at 3:30 in the morning because he couldn't figure out where $980 came from, and we ended with a system that relies on cryptographic tokens and API verification to ensure financial integrity.
And that transformation happened fast. It shows that sometimes the most robust engineering comes from the most intense user frustration. The user's refusal to accept good enough forced the architecture to mature.
It really highlights that idea that the edge cases, like a batched payout, are actually where the real system needs to live. If you only design for the happy path where one client pays one invoice and it hits the bank alone, you haven't built a finance platform.
You've built a toy. Real finance is messy. Real finance is batched. Real finance involves fees and refunds and timing differences. Building a system that handles that mess with mathematical precision is the real challenge.
So what does this mean for you, the listener, whether you're a developer or just someone trying to balance their own books?
It means you should look at your own tools and ask, are they guessing? When your software says match found, is it actually checking a token or is it just saying, hey, the dates are close, good luck?
That is a scary question to ask, especially at tax time.
It is. But as we saw today, the technology exists to stop guessing. We just have to demand it, just like our architect did at 3:03 in the morning.
A huge thank you to the Bytefo team's documentation for giving us this incredible window into the development process. It's really rare we get to see the messy middle of future development like this.
Truly fascinating stuff.
That's all for this deep dive. Go check your bank feeds, people. We'll catch you on the next one.